Download this code from codegive.com, link in the description below. Fixing async loops with iifes in JavaScript, a comprehensive guide. Asynchronous operations are fundamental to modern JavaScript, especially in web development where you interact with APIs, perform I/O operations, and handle user interactions without blocking the main thread. However, using asynchronous operations within loops can lead to unexpected behavior due to the way JavaScript handles closures and variable scoping. This tutorial will explore the problem of incorrect variable capturing in asynchronous loops and demonstrate how immediately invoked function expressions, iifes, can provide a robust solution. Understanding the problem, closure and variable capturing. Before diving into iifes, let's understand the root cause of the problem. In JavaScript, closures allow a function to remember the variables from its surrounding scope even after that outer function has finished executing. This is powerful, but it can also lead to issues when combined with loops and asynchronous operations. Consider this seemingly simple example. Why does this happen? Here's a breakdown. 1. The loop executes quickly. The for loop completes almost immediately. By the time the loop finishes, the value of I is 5. 2. Asynchronous execution. Set timeout schedules the anonymous function to be executed later, after the 1-second delay. 3. Closure and variable capture. When the set timeout callbacks finally execute, they are using the value of I as it exists at that point in time. Because the loop has already finished, and I is now 5, each callback ends up logging the same value. Each callback function forms a closure over the same variable I, which has been modified after each iteration. While let doesn't always solve the problem, but often does. You might think using let instead of var will automatically fix this issue. Let creates a block-scoped variable, which means a new variable I is declared for each iteration of the loop. This often solves the problem in simple cases. This works because let effectively creates a new I variable for each loop iteration. Each set timeout callback then closes over a different I variable, each holding the correct value from its respective iteration. However, let isn't a magic bullet for all async loop problems. Consider a more complex scenario involving an API call. While let handles the loop iteration, the order of asynchronous operations is not guaranteed. Fetch data calls happen in parallel, and the responses arrive at different times. You might want a guaranteed order, or to chain operations that depend on the previous result. The solution: immediately invoked function expressions, iifes. An iife, immediately invoked function expression, is a JavaScript function that is defined and executed immediately after its creation. It's a powerful tool for creating closures and isolating scope. By wrapping the asynchronous operation within an iife, we create a new scope for each iteration, effectively binding the current value of loop variables to the function's context. Here's the basic structure of an iife. How iifes solve the asynchronous loop problem. The key is to pass the loop variable, example I, URL, as an argument to the iife. This creates a new variable within the iife's scope that holds the correct value for that specific iteration. Let's rewrite the set timeout example using an iife. Explanation. 1. Function, j. I, this is the iife. Function, j. Defines an anonymous function that accepts one argument, which we'll call j. I, immediately invokes the function, passing the current value of I as the argument. 2j inside the iife*, the argument j inside the iife acts as a local copy of I for that specific iteration. 3 closure over j*, the set timeout callback now closes over the variable j, which has the correct value from its iteration. Because each iife invocation creates a new j variable, each callback gets a different value. Applying iifes to the API call example. Here's how to use an iife to control the order of API calls and guarantee data processing order, if that's your goal. This assumes you want to process the data in the same order as the URLs. We'll use async/await for cleaner syntax within the iife. Important improvements and considerations *. 1. Making it sequential *. If you need to guarantee that the API calls are made sequentially, one after the other, waiting for each response before making the next call, you need to use await outside of the iife within the loop. This makes the loop effectively synchronous with respect to the API calls. In this sequential version, we don't need an iife because the loop waits for each fetched data to complete before moving on to the next iteration. There's no issue with closures over changing variables. However, this approach is much slower than the parallel approach with the iife because it does not leverage the potential for parallel execution. 2. Replacing loops with map or for each *. In many cases, you can refactor your code to use array methods like map or for each combined with promise.all for cleaner and more efficient asynchronous processing. *urls.map, this creates a new array of promises. Each promise represents the result of calling fetched data for a specific URL. *promise.all, promises, this waits for all the promises in the promises array to either resolve, succeed, or reject, fail. It's a very efficient way to execute asynchronous operations in parallel and know when they've all completed. If any promise in promise.all rejects, the entire promise.all will reject. 3. Error handling * always include proper error handling in your asynchronous code using try, catch blocks. This prevents unhandled exceptions from crashing your application. 4. Understanding this context *, be mindful of the this keyword inside the iife or the asynchronous callbacks, as its value might not be what you expect depending on the context. Complete example with error handling and promise.all *. Key takeaways. Asynchronous loops and closures. Asynchronous operations within loops can lead to unexpected behavior due to closure over loop variables. iifes for scoping. iifes create new scopes for each iteration, allowing you to capture the correct value of loop variables. *let is helpful, but not always enough. *let provides block scoping, which often solves the problem but not always in complex asynchronous scenarios. *map and promise.all for efficient concurrency. *use map and promise.all for cleaner and more efficient asynchronous processing, especially when you want to execute multiple asynchronous tasks in parallel. Error handling is crucial. Always include robust error handling in your asynchronous code. Choose the right approach. Decide whether you need sequential execution, using await directly in the loop, or parallel execution, using iifes, map, and promise.all, based on your specific requirements. By understanding the nuances of asynchronous operations and closures, and by utilizing techniques like iifes, map, promise.all, and proper error handling, you can write robust and predictable asynchronous JavaScript code. Remember to choose the solution that best fits the specific requirements of your application.